Hi, yeah, I'm Sophie. I'm a PhD student at the University of Oxford, and this forms the first sort of chapter of my thesis, which is all about volcanic activity in the Campanian region in the lead up to and following on from large volcanic eruptions. We've all just done Campanian Ignimbrite, but we'll go into a bit more detail. So the Campanian volcanic zone is comprised of 4 volcanic systems. We have the 2 islands of Ischia and Procida, as well as the large Campiflagre volcano and Vesuvius. We know that both Campiflagre and Ischia have produced large caldera-forming eruptions in the past 100,000 years. From Ischia, we have the Monte Epomeo Green Tuft at around 56,000 years, and we know that Campiflagre has produced at least 3 caldera-forming eruptions within the past 40,000 years, and the largest of these being the Campanian Ignimbrite at around 40,000 years ago. This eruption was so large, it is a key marker across the southern Mediterranean and has been dispersed as far east as Siberia. And because it was so explosive, this was a very erosive eruption, and thick ash has been deposited subsequent. So this has made it very difficult to understand the stratigraphy prior to the Campanian Ignimbrite. Work that has been done on subsequent post-CI deposits have revealed lots of eruption deposits, but most interestingly, we do see these phases, these shifts in the magma system over time. So whilst I've mentioned that the eruption stratigraphy is not well constrained prior to the CI, we have from the literature seen previously published sites that do have deposits from Campiflagre prior to the Campanian Ignimbrite all across the Campanian plain here. However, many of these units are lacking in geochemical data, which is quite problematic. And then in the distal realm as well, and across Italy and also into Greece, geochemical data from both visible and cryptotephra layers have revealed the presence of pre-CI Campiflagre activity. But again, the lack of the characterization of these proximal units has limited their use in terms of correlations, which are quite tentative. So a bit more detail again about the eruption stratigraphy. So for Campiflagre, recent argon dating of pre-CI deposits from the Apennine Mountains, which are just behind where the strat column is there, have revealed there are at least 5 deposits dating to 100,000 years ago, but we don't know much what's happening between 100,000 and 40,000 years ago. And in contrast, we have Ischia, where we know that the MECT happened about 56,000 years ago, and between that and the CI, we have at least 6 characterized logged deposits, which don't all have geochemical data. We do also have the island of Procida, again, quite incomplete. And for Vesuvius, whilst it's part of the Campanian volcanic zone, it's not active prior to 30,000 years ago. And the aim of my research is to build up the tephra stratigraphy for the pre-CI deposits for this region. So I haven't included the strat column for Vesuvius there. So my study site, so because we want to refine the tephra stratigraphy for the pre-CI deposits, we take one of these proximal sites called Aquamorta. It's also referred to as Monte de Procida within the literature. It's a lovely beach sequence, great for some field work. And we can see it's located on the western perimeter of the CI caldera wall. So it's just located outside, so should be better preservation of the deposits. The site has previously been logged. However, the number of deposits within the sequence beneath the CI is disputed. We have had the MECT identified within the deposit as well, and previously published from this site. So we do have several of the key units from this region, including the CI and the MECT. We sampled from sequences across the outcrop here. Only deposits between the MECT and the CI were accessible, so those were the focus of my research. So we identified 12 units between the CI and the MECT. Sorry, it hasn't included all my data, so the CI is at the top here and the MECT is just in here. All of these units vary in thickness, vesicularity and colour. We have several paleosols between each of these units. They are well-defined units. In terms of our geochemical results, all of our units are very compositionally similar, and there's little heterogeneity both within a deposit and between units, which is quite problematic. However, we have been able to identify 2 volcanic sources based on major element data, comparing it to deposits which have been characterised previously from some of the proximal sites. So we have 3 units from Ischia here in green, and the remaining 9 units comprise of the Campanian of Campiflograe origin. We have then been able to subdivide these Campiflograe groups into 3. So we've got Group B, Group C and Group D, all from Campiflograe, and we did obtain trace element data also. So if I go quickly on to our first group, which is Group A, so these are our Ischia layers, all 3 are indistinguishable in terms of their geochemistry, both on major and trace elements. So we have not been able to pull them apart individually, but we can see their stratigraphic position, their thickness, in colour, they do vary. They show a geochemical affinity with the Scarpone eruption, which occurs between the MECT and the CI, and we do have geochemical data for this unit. It has also been reported in other sequences across the region, both in marine and within the Lago di Monticchio record, which Vito was just talking about. However, we have 3 units with this chemistry, so this is quite important to recognise that if you find something with the Scarpone chemistry, it's not necessarily the Scarpone, even on the trace element data. We can't pull it apart. Our first Campiflograe group is Group B. These are the 2 deposits at the base, just above the MECT unit. This Campiflograe group is the most distinct of the 3 Campiflograe groups. It has a lower silica content and higher potassium content. Of pre-CI deposits that we have previous geochemical data for, it overlaps with the TLF unit from Trefala. And again, this unit is largely considered a very distinct Campiflograe pre-CI deposit. As we can see here. However, again, we have 2 units which, even on trace element data, we cannot distinguish which one could correlate to the TLF. So again, we urge caution if you correlate to the TLF unit within your distal or even proximal sequences. Thirdly, we have our Group C, which is our bulk of our analyses here. We have 5 units which are interspaced by Ischia units. We have not been able to correlate these to any pre-CI deposits, and they're largely indistinguishable again. However, we do observe that the upper 2 units, AQ9 and AQ10, do cluster in both major and trace element data, as we can see here by the red circle. And finally, we have our Group D, which are the 2 uppermost units deposited directly beneath the CI. Both of these units were also quite similar geochemically to the pre-CI Group C. We do see a partial overlap with the CI, which we didn't for the previous group. Therefore, that's why we've characterised it as a distinct group. Most interestingly, these deposits show a partial overlap with the TM181A to D tephra deposits observed within the Monticchio record, and all of these 4 eruptions occur within 600 varv years before the CI, which are compositionally similar to the Campanian Ignimbrite. We've not been able, even on trace elements, again, to correlate which one, if any of these, correlate to the TM181A to D tephras. Similarly, other records across the region, including as far away as Greece, have found several of these deposits several meters below the CI and have argued that they may be reworked deposits. However, finding these proximal units with similar CI chemistry might change some of these decisions. So in conclusion, Campiflograte and Ischia produce eruption deposits with repeated chemistries. This is significant, particularly for the Scopone and the TLF, as these are considered distinct geochemical units previously to help and aid correlations. So we urge caution if correlations made into both the proximal and distal realm using pre-CI deposits until we have further data from other outcrops around the caldera, which we're working on. Thanks for listening.